Let's study about coordination chemistry, starting with the definition of coordination compounds. So what are coordination compounds? Compounds in which metal atoms are bound to a number of anions or neutral molecules through coordinate bonds. So coordination chemistry is a branch which falls under inorganic chemistry, wherein we deal with coordination compounds which show a presence of the coordinate bond. Coordination compounds are simple yet complex compounds in which you have a metal atom which is surrounded by a number of anions or neutral molecules, and the entire structure is held together through coordinate bonds. So before we proceed to the core part of coordination chemistry, there are a few important terms we need to understand. The very first term is coordination entity. Coordination entity can also be referred to as the coordination sphere. The coordination entity or the coordination sphere is made up of the central metal atom or ion bonded to a fixed number of ions or molecules. Let's try to understand each of this term by taking an example. So the very first example which I have put over here, it's a complex of cobalt with chlorine and ammonia. Okay, so this entire figure, this entire structure that we have, that is your metal atom along with the attached ions, the groups which are attached to it, the entire structure is known as a coordination entity or the coordination sphere. Okay, similarly, second example is of nickel. It's a carbonyl complex of nickel. This is also entirely a coordination entity. And the third example, which is a complex of iron with cyanide, this is also a coordination entity. Okay, so you have the metal attached to a fixed number of neutral molecules or ions. Okay, and that represents the coordination entity. Coming to the next term, central atom or the central ion. Okay, this is basically the metal atom or the metal ion which is present in your coordination compound. Okay, now in this particular case, the metal that we are dealing with is cobalt. Okay, in this case it is nickel. Yes, and in this case it is iron. Fine. Now in different examples, the central metal can either be an atom or it can be an ion, and we're talking about the cationic form because metals are electropositive and they are more stable with the positive oxidation state. Okay, so if you look at the first example, we have cobalt. Cobalt over here will be present in the cationic state, that is cobalt will carry an oxidation state of +3. Okay, whereas nickel over here is present as an atom. Okay, because in this example a nickel carries a 0 oxidation state. Okay, so this is cationic, this is an atom. And the last one, in the case of iron, iron is going to carry an oxidation state of +3. Okay, so first we discussed what is the coordination entity, and now we looked at the central metal atom or the central metal cation as per the example that you are dealing with. The last important term we have is ligands. Okay, so the ions, which are obviously anionic or negatively charged, okay, or molecules when they are neutral bound to the central metal atom or ion, they are known as ligands. Okay, so ligands are these fixed number of molecules or anions present around your central metal atom. Fine. In some cases they can be neutral, that is they do not carry any charge, or in other cases they can be anionic, that is negatively charged. Okay, so the ligands in this particular example, we have chloride, which is obviously negatively charged, and the second one is ammonia, which is neutral, does not carry any charge. Okay, similarly in the second example, the ligand that we have is carbonyl, that is again neutral in nature, and in the third example we have the ligand as cyanide, which is anionic in nature as it carries a -1 charge. With that, I will conclude today's video. Thank you so much for watching. If you guys did like this video, give this video a thumbs up and follow my channel more for such content. Thank you.